Okay, polynomials are mathematical expressions, which just means a combination of terms that cannot be simplified anymore. And that comes from the word poly, meaning many, and nomials, meaning numbers. So, for example, 2 plus 5 equals 7. So that's a monomial, because I can combine these two. If I say 2 plus x is equal to 2 plus x. Okay, so that's a binomial. I can't combine them any more than what they've already been combined as. So that is already simplified. So that's a binomial. 3 terms, a trinomial, and so forth. We just refer to all of them as polynomials, and it usually means when we're dealing with variables. So, when I'm adding polynomials, I have to make sure that I combine like terms. That's the only way I can add them, is by combining like terms, which means terms that have the same characteristics as others. Here I have an x, and over here I have an x. Here I have just a constant number, and here I have a constant number. So I'm combining like terms. I'm combining the 2x and the x, but it's addition. So 2x plus x, and x by itself just means 1x. 2x plus 1x is 3x, and 3 plus 5 is 8. So now I've simplified this polynomial above here into this by combining like terms. Well, like terms applies to any kind of variables. So if I have like a 3x plus 4y plus 2z plus 8y, then can I combine this 3x with anything? No, this is 4y, that's 2z, and that's 8y. So the 3x stands alone. I usually cross them out as I'm doing them so I can keep track. Now, can I combine this 4y with anything? Can't combine it with the 2z, but I can combine it with the 8y. So now I get 12y. Cross those out. And now 2z, that's the only thing left, so I just leave it as is. So now I've simplified all of that by combining these two terms here, because they are both y's, into this one here. One has to be careful when some of these variables have exponents. For example, if I've got x squared plus 3x plus 2x squared minus 5x, even though this variable here is an x and this is an x, we have x's all the way across, because two of these have exponents, I can only combine them with the variable, with the same variable with the same exponent. So in this case, I can only combine the x squared and the 2x squared into 3x squared. Notice that when I'm adding these polynomials and combining like terms, the variable or the exponent stays the same. It's not like law of exponents when you're a product of a product or a power of a product or whatever. Okay? When I'm combining them, the exponent stays the same. So x squared plus 2x squared is 3x squared, and then I've got 3x minus 5x, don't forget that sign, 3x minus 5x would be minus 2x. And now I've combined them, combined like terms, and taken into account that I cannot combine the x squared and the x's. Okay, if I look at this little more complex polynomial, you notice I have an x squared here, x squared y. But what that means is I need to look for another x squared y. Okay, I have a y over here, but it's not an x squared y. And I have an x squared here, but it's not an x squared y. So when I have this x squared y up front here, I can't combine it with anything else because I have to meet with another x squared y. So that stands alone. Then I go to the next term, 2y squared. There's an x squared here, and a y over here, and a 2, so I can't combine that with anything. Then a 3x squared. Can't combine that with anything. Minus 4y plus 2. So the way I originally wrote it was already simplified. Because the variables weren't an exact match, I could not simplify or could not combine like terms. And that's something that you need to be careful with. They have to be an exact match as far as the variables and their exponents go. That's how you add and subtract polynomials.